Pipelining by itself is a fairly simple process. If I wanted to do it in general, right, let's just take a simple chain, right, and let's say that the execution times of these are something like 5 time units, 10 time units, 25 time units, and once again 10 time units. Right now the critical path is how much? It's 5 plus 10, 15, 25, 40, 50 time units. What is the minimum that I can get to if I cannot add any extra hardware other than registers? 25. So my bottleneck in this case is ultimately going to be this node, which has the maximum delay. It becomes a bottleneck because that is the slowest unit in my pipeline. And how do I go about pipelining over here in order to actually get my critical path down to 25? It basically means that this unit C cannot be combined with any other unit in the same clock cycle or in the same iteration interval, right? Because the moment I add some other functionality, the critical path delay is going to go above 25. So one thing that is obviously guaranteed is I need to have a register here and a register here, which now tells me that although I could have added a register between A and B, that's unnecessary because it does not really help me in any way. My critical path has already come down to 25 and the AB delay is only 15, right. So adding an extra register at AB is not wrong, there is no problem with it, functionally you will be perfectly fine, but is unnecessary in this case. How do you solve this problem in general? There are systematic ways of doing this, right. I am not going to go into that because one is that those processes can be automated and most tools nowadays will take care of this for you, the fine grained pipelining details. But if you do need to do pipelining by hand, usually it will be in a situation where the circuit is simple enough and you can visually observe that this is going to be the critical path, this is the portion I need to isolate, and the rest of the things I put in whatever are the minimum number of registers I need in order to make sure the critical path does not exceed my target. Usually this is also called balancing, right. What you want to do is, if I want to break my circuit into 2 parts or 3 parts, I try and balance things out so that the delays are pretty much equalized on all sides. In this particular instance, supposing I had told you that you are allowed to only use one extra register, what would you do? What's the best that you can do? Where would you place that register? That is, if only one extra register is permitted, where should you place it to minimize the critical path with the same delays? So 5, 10, 25, 10. Either I can put a register either on the edge between A and B, or between B and C, or between C and D. That's it. Those are my 3 options. Where should I place it? In this case, between B and C would be the only sensible place to put it, right? So I end up with 35 on this side, 15 on this side, not balanced, but at least better than any of the other options, because for example, if I had put it here, this would have been 5 and 45, or if I had put it over here, I would have ended up with 40 and 10. So this one happens to be the best. Okay. So depending on how many registers you are willing to invest or spend on pipelining, you can decide how much improvement in your critical path you want to achieve. Okay. So if you have more registers available to you, you may want to do additional pipelining. Okay. There is a flip side to this, which is that registers don't come for free. One is they occupy area. The second thing is, the part that I am not mentioning at all, or that I have not shown over here, is registers themselves have a certain capacitance associated with them, which means that they have a propagation delay on their input side, the so called clock to Q, or on the output side is the clock to Q output delay of the register, and on the input side they have a setup delay. So each time I add a register over there, that is also going to become additional overhead, and therefore the reduction in critical path that I get may not be as much as I expect it to be. So once I have got down to the point where my critical path itself is of a similar order to the clock to Q or setup delays of a register, you are not really going to get any further improvements by pipelining.